Hello everyone. Today I will discuss with you the concept of aromaticity in super easy way. So what is aromaticity? Aromaticity means extra stability in cyclic conjugated compounds. It comes from delocalized pi electrons moving around the ring compounds. For example, benzene, cyclobutadiene, cyclopentadienyl anion, pyrrole, pyridine, etc. So before starting, you must know what are pi electrons and how to count them. So pi electrons are the electrons present in pi bonds that are double or triple bonds. They come from sidewise overlap of p orbitals as shown. Each pi bond has 2 pi electrons. So to find aromaticity, only pi electrons are counted, not sigma electrons. For example, ethene has one double bond, so 2 pi electrons. Benzene has 3 double bonds, so 6 pi electrons. So to count pi electrons, remember each double bond contributes 2 pi electrons, each triple bond contributes 2 pi electrons. A lone pair can also give 2 pi electrons if it is part of conjugation. Never count sigma bonds. But what is conjugation? It means alternating single and double bonds, one single, second double, and so on. That creates continuous overlap of p orbitals. Electrons can move freely, which we call delocalization. For example, 1,3-butadiene, there is alternating single and double bond, so it's conjugated. In benzene is also fully conjugated, so very stable. Cyclohexane has no pi bonds, so it is non-conjugated. Let's count pi electrons by taking some examples of conjugated systems. For example, in benzene there are 3 double bonds, so 6 pi electrons. In cyclobutadiene, 2 double bonds, so 4 pi electrons. In cyclopentadienyl anion, 2 double bond plus 1 lone pair, so 6 pi electrons. In pyrrole, 2 double bonds plus lone pair on nitrogen atom, so 6 pi electrons. In pyridine, 3 double bonds, so 6 pi electrons. The lone pair on nitrogen atom does not join in conjugation here. That is how you can count the pi electrons. Now, for a compound to be aromatic, it must follow 4 essential rules. It should be cyclic, planar, fully conjugated, and obey Huckel's rule. If all conditions met, then it is aromatic. If there are 4 and pi electrons, then anti-aromatic. If not conjugated or non-planar, then non-aromatic. So Huckel rule says if a ring has 4 n plus 2 pi electrons, it is aromatic and equals to 0, 1, 2, 3 and so on. So if n equals to 0, it means 2 pi electrons. N equals to 1, so 6 pi electrons. N equals to 2, so 10 pi electrons. N equals to 3 means 14 pi electrons and so on. Let's understand by examples. So benzene with 6 pi electrons is cyclic, planar, conjugated and follow Huckel rule, so it is aromatic. Cyclobutadiene with 4 pi electrons is cyclic, planar, conjugated but do not follow Huckel rule, so it is non-aromatic. Cyclopentadienyl anion with 6 pi electrons also follows all rules. So aromatic, similarly pyrrole and pyridine are aromatic, but hexane is non-conjugated and non-planar, so does not follow Huckel rule, so non-aromatic. So first count pi electrons, then check if structure is cyclic, planar and conjugated and follow Huckel rule or not. If there are 4n plus 2 pi electrons, then it is aromatic. 4n pi electrons, then anti-aromatic, and if conjugation is missing, then non-aromatic. Aromaticity gives extraordinary stability to the molecule. Follow deep chemistry for more quick chemistry lessons. This is Dr. Gagan making chemistry crystal clear.